puedo cantar. No, puedo.
The goal of this experiment is to design our own titration, and we decided to use sodium hydroxide and hydrochloric acid, which is a strong base and a strong acid, and we're going to titrate those together.
Welcome to how to do an acid-base titration. Before we start our lab, we're going to make sure that we're in our proper lab equipment with our hair tied back, goggles on, apron. We're going to wear gloves because we're dealing with a high molar acid, and make sure that you're wearing closed-toed shoes. Alright, let's begin. Alright, so in our burette we have 50 milliliters of sodium hydroxide, which is chemical formula of NaOH. It is a 0.1 molar, and in our beaker we have 50 milliliters of hydrochloric acid at 0.2 molar. Alright, before we start we're going to add our indicator, and our indicator today is phenolphthalein. We're going to add 3 drops of phenolphthalein before beginning. Now if you record the pH level, right now our starting pH is 1.37. We're going to begin by starting our magnetic stir. As you can see, our pH meter is measuring the pH as we slowly start to titrate the NaOH into the HCl. We're going to open our stopcock and slowly put it in. Now, how we're going to know that this solution is neutralized is that the indicator is going to turn the HCl pink. Now, we're going quite fast here, but we're going to start slowing down and letting the acid do its work. Right now, our pH level is at 1.57. Now, the solution to be neutralized should be at 7.0. And that is the perfect balance that we're going for right now. Okay, as you can see, the color is turning slightly pink as the NaOH is added. We're almost out of our 50 milliliter solution of NaOH, so we're going to add some more into the burette before we begin again. Okay, using a funnel and my slightly taller friend, we're going to fill the NaOH back up into the burette to another 50 milliliters. Stopping slightly from the top, we're going to remove the funnel and fill in the rest with a disposable pipette. Now this just ensures that we get it exactly 50 milliliters into the burette. Alright, now that we've filled the NaOH back into the beaker, the burette, we're going to start titrating really slow because it is taking longer for it to stop turning pink. And doing this ensures that we do not go past the equivalence point that we're looking for. Alright, I have now finished titrating the final drop into the solution. The pH now is 7.23. Now this is as close to neutral as I can get it, and as you can see from the beaker that the solution is very, very lightly pink. You can barely even see the indicator solution in there, and this is what we want. I'm going to stop the magnetic stir and take it off, and I'm going to show you a little closely. But you see that? It's slightly pink, it's not too pink, and if we had gone 1 drop more over than this, it would have turned very, very fuchsia, and the pH would have jumped significantly higher than it is now. So this right now is as close to neutral as we're going to get it. Awesome! Alright, so in the end we titrated 52.6 milliliters of NaOH into the 25 milliliter HCl solution to reach the perfect equivalence point.
Are you done, Vicky? Where do we get the